Hello everyone. So welcome to the last video number patterns. So kule video sizokwenza amanye ama question from section number pattern. So discussa question paper exemplar yaka 2014. So sizokwenza question 2 no question 3 ngaphandle kokuthi simoshe isikhathi asivele siye lapha ku question 2. But given the arithmetic series 18, 24, 30 to all the way to 300, determine the number of terms in this series, calculate the sum of the series, and calculate the sum of all the whole numbers up to and including 300 that are not divisible by 6. Okay, so lapha ku 2.1 basitshela ukuthi we have an arithmetic series, right? So because it's an arithmetic, we know that we have a common difference somewhere, right? And then question 2.1.1, but it determine the number of terms in this series. Okay, so it's an arithmetic series. It means we have a common difference there. So let us go ahead and calculate the common difference. So our common difference will be the second term minus the first term. So sizoti 24 minus 18, and then sithola ukuthi the second difference yethu ngo first common difference yethu, sorry, it's 6, right? And then we know ukuthi first term is 18. So therefore, applying this formula yaka Tn is equals to a plus n minus 1t. Sizokuthola ukuthi Tn is equals to 18 plus n minus 1 times 6, right? So sizoba no 6n minus 6 plus 18, right, which is equals to 6n plus 12, right? So our Tn will be 6n plus 12, right? So we want to calculate the number of terms in this series. We know the last term is 300, right? And then we want to calculate how many terms are there. So from this equation we need to solve for n, right? So n is equals to 300 minus 12 divided by 6, which is equals to let's press our calculator. Set 300 minus 12 all divided by 6, so total n is equals to 48, right? So lapha ku 2.1.1 sino n is equals to 48. So this series has 48 terms, right? Okay, so I think so the line create space for 2.1.2. 2.1.1 stoluti n is equals to 48. So there are 48 terms in that series. Now they want us to calculate the sum of this series, right? So the sum of the series is 2.1.2. the sum of the series we are given, sorry, because we know what is an arithmetic series, we know what we can apply this formula here. Sn is equals to n over 2 times the first term plus the last term, right? So, or you can use this one. Okay, so between these two type, now we'll go with this first one here. So we know the value of n is 48, and then we know the value of the first term is 18, and then we know the last term is 300. So we can somewhat substitute as 48 is equals to, okay, so when most of you are calculating a sum a series, you say Sn is equals to and then you go maybe substitute 48 there and divide by 2. Remember what the Sn is just the sum of the first n terms, so I will be specific if the Sn is equals to 48. I ends the sense. So when you substitute, make sure what you substitute everywhere. So where you see n, put 48. Don't write Sn is equals to 48 over 2. Write S48 is equals to 48 over 2. Mistaking ibonile leyo. So baluguthi S48 is equals to, now the S48 you specify what we are summing the first 48 terms, right? Now the Sn uchazuthi we are summing the first n terms, but because we know what how many terms are there, we should specify, be specific with how many terms you are summing, right? So we say S48 is equals to 48 over 2. The first term is 18, the last term is 300, right? So you can straight away punch this ku calculator yako. So uzothola ukuthi now punch this in your calculator, the sum of the series is 7,632, right? So S48 is equals to 7,632, right? Izosula futhi and create space for 2.1.3. Okay, so 2.1.3 2.1.3 bathi calculate the sum of all the whole numbers up to and including 300 that are not divisible by 6. Here they want us to calculate the sum of all the whole numbers up to and including 300 that are not divisible by 6. So in the list of approaching this question is, first we need to calculate the sum of all the whole numbers including those that are divisible by 6, right? So consider the sequence, the sum of all the whole numbers up to and including 300. So sizoba a sequence ilena 1 2 3 4 all the way to 300, right? So this is a sequence of all the whole numbers up to and including 300, right? So notice ukuthi this sequence is an arithmetic sequence. Ne? The first term there is 1 and the common difference is also 1, because to move to the next term you're adding 1, right? So if you calculate the sum of this series, okay, if you add all the terms in this sequence, you will have the sum of all the whole numbers up to and including 300. In that sum you will also be including those that are divisible by 6, right? But the equation lapha ithi we want the sum of all the whole numbers up to and including 300, but then you should not include those that are divisible by 6, right? So in order to do this, let us first calculate the sum of all the whole numbers including those that are divisible by 6. Yeah? So from this sequence, if you add all the terms, you'll have the sum of all the whole numbers including those that are divisible by 6. So in this sequence we have 300 terms because it's 1 2 3 all the way to 300. So our n there in this sequence will be 300, right? So it's an arithmetic sequence, so we will apply this formula for Sn, the first term plus the last term, n over 2 times the first term plus the last term, right? So we are summing 300 terms, yeah? The first term is 1, the last term is 300. So this will represent the sum of all the whole numbers, including those that are divisible by 6, right? The sum of all the whole numbers up to and including 300. In this sum, we also have those terms that are divisible by 6, right? So if you punch this in your calculator, you'll get that the sum of all the whole numbers is 45,150, right? So this is the sum of all the whole numbers up to and including 300, right? In this sum, we also have the terms that are divisible by 6 in this sum. But then equation ET, we should calculate the sum but exclude those that are not divisible by 6. But calculate the sum of all the whole numbers up to and including 300 that are not divisible by 6, right? So they want the sum of the terms that are not divisible by 6. So if you consider that sequence again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, all the way to 300. They wanted the sum of all the terms, but then we should not include those terms that are divisible by 6. So O1J, we have the sum of all the terms, right? We have the sum of all these terms, including those that are divisible by 6. So looking at this list, this one is divisible by 6, because 6 goes into 6 once, and then this one is also divisible by 6, right? And then we only want those ones that are not divisible by 6. We want the sum of all the terms, but then exclude these ones that are divisible by 6. So if you go back to our original sequence there, notice ukuthi all these terms are divisible by 6, right? All these terms are divisible by 6. All of them are divisible by 6. Therefore, lapha ku 2.1.2, we have a sum of the terms that are divisible by 6, right? We have a sum of the terms that are divisible by 6, right? So okay, I think Bali this sequence of all the whole numbers up to and including 300. So zoba no 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Sorry, Pala this because I want to explain this properly. Right, 25, 26, 27, 28, 29, 30, right, all the way to 300, right? So equation it wants the sum of all the whole numbers up to and including 300, but then in that sum we should not include those that are divisible by 6. So here we have a list of all the whole numbers up to 300. They want the sum of all these terms, but then we should not count the ones that are divisible by 6. So the ones that are divisible by 6 is 6, is 12, is 20, it's 18, 24, 30, and then 300 is also divisible by 6, right? So notice ukuthi in our original sequence, we have the term 18, we have 24, we have 30, and then we have 300. So this sequence, it only has terms that are divisible by 6, right? And then we've calculated the sum to be this one here. So if we have this sum of all the terms up to and including 300 to be 45,150, in this we have those that are divisible by 6. So to answer this question, we need to take this sum and remove the terms that are divisible by 6. Remove the sum of the terms that are divisible by 6. So okay, so to answer the question, ngiyathemba ukuthi iyazwakala ngendlela engichaze ngayo. So to answer this question is ukuthi the sum of the terms that are divisible by 6 is the sum of all the whole numbers up to and including 300 that are not divisible by 6 is equals to the sum of all the terms, the sum of all the whole numbers up to and including 300 minus the sum of the terms that are divisible by 6 from our original sequence there, right? And then minus, because okay, so if with the original sequence these numbers are all divisible by 6, the numbers before these that are divisible by 6 is 6 and 12, right? So they are not included in this sum here. So they are not included in this sum. So we need to subtract them also from that 45,150. So we need to subtract 6 and subtract 12 again. So the answer to this question will be 37,500, right? Okay, I'm hoping ukuthi it makes sense ngendlela engichaze ngayo, right? Okay, so let us move on to another part here, question 2. Alright, so but the first three terms of an infinite geometric sequence are 16, 8, 4, and so on. Determine the nth term of the sequence. So lapho bafuna iformula yaka Tn, right? So because basitshela ukuthi it's in a geometric sequence there, we know ukuthi we will apply this formula for Tn, right? They tell us ukuthi the first three terms are these ones. So the first one is 16, sorry. So we know ukuthi A is 16 there. Then we can calculate the common ratio by taking the second term divided by the first term. So if you say the second term is 8 divided by the first term is 16, the common ratio is equals to 1/2, right? The common ratio is equals to 1/2. So now the formula for Tn is therefore Tn is equals to 16 times 1/2 to the power n minus 1. That's the formula for Tn there. 16 times 1/2 to the power n minus 1. Okay, that's question 2.2.1. And then 2.2.2, but determine all the possible values of n for which the sum of the first n terms of the sequence is greater than 0, sorry, greater than 31. So they want the values of n. We want the values of n such that the sum of the first n terms is greater than 31, right? We want the values of n. We want the values of n. We want the values of n, right? Such that the sum of the first n terms is greater than 31. So in order to do this, we have to find the value of n where the sum of the first n terms is equals to 31. So we want, let us get n. Let us first get the value of n where the sum is equals to 31, right? So we know what the sum of a geometric series is a times Rn minus 1 divided by R minus 1. Okay, since R is less than 1, let me apply the other version of the formula. So sizoti a is equals to 1 minus Rn, a times 1 minus Rn divided by 1 minus R equals to 31. So we want to solve for n, right? We know the value of a to be 16, and then we know the common ratio to be 1 over 2, and then 1 minus 1 over 2, right? Now simplifying this, we want to solve for n lower up, ne? So with denominator we have 1 minus 1 over 2, so we have 1 over 2, and then if you take that 1 over 2 and cross multiply it lapha ku 31, uzoba no 31 over 2, right? So okay, so sizoba no, okay, I think to begin ngapha sizoba no 16 times 1 minus 1 over 2 to the power n is equals to 31 over 2, ne? And then divide throughout by 16. So toluguti 1 minus 1 over 2 to the power n is equals to 31 over 32, right? Now 1 over 2 to the power n will be equals to 1 minus 31 over 2, which is 1 over 32. So now solving for exponential equations, we know what we have to make the bases the same and equate the exponents. So 1 over 2 to the power n is equals to 1 over 2 to the power 5. So another way of writing 1 over 32 is to say 1 over 2 to the power 5. So this means that n is equals to 5, right? So for the sum to be equals to 31, we need to sum the first 5 terms. So but then tina sifuna the values of n where the sum will be greater than 31. The sum of the first n terms will be greater than 31. So if you say S4, if you substitute 4 lapha ku n, uzobona ukuthi the sum of the first 4 terms will be will be equals to 30, right? So S4 is equals to 30. S5, when you substitute 5 lapha uzothola ukuthi it's 31, right? So it's 31, right? And then if you say S6, if you say S6 uzothola ukuthi this is equals to 31.5, right? So therefore n has to be greater than 5, so that when you sum the first n terms, the sum is greater than 31. So n, our final answer is this one. N has to be greater than 5, right? For the sum of the first n terms to be greater than 31. When n is equals to 5, the sum is just 31. When n is less than 5, the sum is less than 31. But when n is greater than 5, the sum will be greater than 31. So it means our n has to be greater than 5. Okay, I hope it makes sense. So our answer to question 2.2.1 is n is greater than 5. And then 2.3, what to calculate the sum to infinity of this sequence. Okay, oops. The sum to infinity of the sequence. Right, so silapho 2.2.3, we know what the sum to infinity of a geometric is given by a over 1 minus r. We know the value of a to be 16. We know the value of r to be 1 over 2. So if you punch this in your calculator, you get that the sum to infinity is 32. Right, and then we are done with question 2. Let us now move on to question 3. Right, the first part of question 3. Okay, let's create space for question 3. Okay, so now question 3, but a quadratic number pattern Tn equals to this has a first term equals to 1. The general term of the sequence, the general term of the first difference is given by this formula, right? So 3.1.1, they want us to calculate the value of a, right? The value of a. So they tell us that term number 1 is equals to 1, right? And then that the formula for the first difference is given by this, right? So we have a quadratic sequence lana, and then we know that the first term is 1, the second term we don't know, the third term we don't know, and the fourth term we don't know. But then we know the formula for the first difference. Remember that the first difference of a quadratic sequence is an arithmetic sequence. So now substituting 1 in this formula there, uzoba no 4 plus 6, uzothola ukuthi the first term of the first difference is 10, and then substituting 2, uzoba no 4 times 2, which is 8, and then plus 6, which is 14. So uzothola ukuthi the second term of the first difference is 14, right? And then substitute 3 there, uzoba no 4 times 3 plus 6, which is 18. and then the third term of the first difference is 18. Now we can easily calculate the second difference now, right? So 14 minus 10, it will give us 4. 18 minus 14, it will give us 4. Therefore, the second difference of this quadratic sequence is 4. So it means that 2a is equals to 4, which means that a is equals to 2. So there, 3.1.1, we have a is equals to 2. Okay, so, and then siyadlula lapho siya ku 3.1.2. So now I'm answering 3.1.2. 3.1.2, but it determines the formula for Tn. We have a to be 2, right? And then we know what 3a plus b has to be equals to the first term of the first difference. So 3a plus b is 10. We have a already. We can just substitute a, and then we can solve for b. B is equals to 10 minus 6. B is equals to 4. Right? B is equals to 4. So now we know what the first term of the quadratic sequence is 1. Therefore, a plus b plus c is equals to 1. We have a to be 2. We have b to be 4. Now we want to solve for c. Right? Therefore, c is equals to 1 minus 2 minus 4. C is equals to minus 1 minus 1 minus 6 is minus 5. So C is equals to minus 5. Right, so the formula for Tn will therefore be Tn is equals to 2n squared plus 4n minus 5. That's the formula for Tn there. 2n squared plus 4n minus 5. That's our formula. Yeah, that's the first part of question 3. The second part says okay, the second part says given this series, write down the series in sigma notation. And then they say it's not necessary to calculate the value of the series. Okay, so now we have a series. They want us to write this series in sigma notation. So notice here, if you consider the number left of this multiplication sign, we know 1, we know 5, we know 9, and then we know 13. So it's probably passing 1, 5, 9, 13. Right? Notice the number to the right of this multiplication sign is 1 more than the number to the left. So if you say 1 plus 1 is over no 2. If you say 5 plus 1 is over no 6. If you say 9 plus 1 is over no 10. If you say 13 plus 1 is over no 14. If you say 81 plus 1 is over no 82. Right? Jalo njalo. So now notice with these numbers to the left of the multiplication sign, they form an arithmetic sequence with the common difference of 4. Right? With the common difference of 4. And then we know what it is equals to 4. And then the first term is 1. Right? So if you were to write the formula for Tn, uzoba no a plus n minus 1d, which is 1 plus n minus 1, 4. So this will be 4n minus 4 plus 1, right, which will be 4n minus 3. So the sequence, the numbers to the left of the multiplication sign, they progress by adding 4 each time. So if you say 1 plus 4 is total 5. If you say 5 plus 4 is total 9. If you say 9 plus 4 is total 13, and so on, right? So therefore, we can also calculate the number of terms in this series, right? Because we know the last term to be 81. So if you say 81 equals to 4n minus 3, and then you solve for n, so total n is equals to 81 plus 3 over 4 is equals to 81 plus 3 over 4 is equals to 21. So we have 21 terms in this series, right? So if I were to write this series in sigma notation, I would say the first we're multiplying, right? So the number to the left side of the multiplication is 1 less than the number to the right. So we have found the number to the left of this multiplication, they progress in this form. They form an arithmetic sequence in this way, and then we found a formula for that sequence, right? So if I were to write this in sigma notation, I know I will sum from n is equals to 1 to n is equals to 21. Okay? So we have 21 terms that we are summing, right? And I know the terms in the left hand side of the multiplication sign there, they progress in this formula with this formula, right? So the one of 4n minus 3, and then the terms to the right of the multiplication, they are 1 more than the term to the left. So if I add 1 to this, I will have a formula for the terms that are to the right of the multiplication. So here I will have 4n minus 2. So this is the formula representing this series in sigma notation. This is our answer here, right? Yeah. So yeah, that's the last question esizoyenza kuma number patterns, and then in our upcoming videos sizodiscussa i-trigonometry. Sizomuvela ku paper 2. I-trigonometry is very important. I think inama marks are 50 out of 150 ku paper 2, if I'm not mistaken. So trigonometry number marks. So that will be our next topic, is by trigonometry, paper 2. Right, that's it for this video. If you have a question, thumelele wona lapho ku WhatsApp, ngizokhona ukuthi ngiwaphendule. Yeah, sharp.